Assalamualaikum and hello everyone. Welcome to our video. This video is an assignment for our engineering survey subject. So we have been assigned to do a project about a construction of a new dam for 30 km square of reservoir area at Melaka. So before we start, I would like to introduce our group. My name is Muhammad Afiq bin Muhammad Syahiran, and the members is Nur Machita binti Nasir and Muhammad Zamir Helmi bin Zainun. Okay, so in this video, we will present about construction of dam from the beginning of the construction until it finish. So throughout the video, we will explain all of these contents from introduction, objective, scope of works, survey instrument, methodology, milestone of project, costing, output, summary, and acknowledgement. So we will start with introduction first. We will move on to the video with our friend Norma Chita.
Hello everyone, my name is Machita. So before we start with our project, I would like to talk about what is a dam. A dam is a barrier that impounds water or underground stream. A barrier constructed across a waterway to control the flow or raise the level of water. So there are a variety of dams a man has been using since the history. However, we can categorize them to understand it more conveniently. Following are the different categories of dams, which are by structure, by size, by materials, or by use. Now we will look at by structure. Based on structure and material use, dams are classified as arch dams. Arch dams and buttress dams can be built using a smaller amount of concrete than that required for a gravity dam, and as a result, are cheaper to build. This is possible because arch and buttress dams are designed to transfer some of the load forces on them the foundation of which they are built. For example, the strength of the foundation is used to help resist the loads, which could not resist it simply by the weight of the dam wall alone. So next, gravity dam. Gravity dams rely on the weight of the material of which they are built to resist the forces like gravity, water pressure, and earthquake to which they are subjected. And arch gravity dams. A gravity dam can be combined with an arch dam into an arch gravity dam for areas with massive amounts of water flow but less material available for a purely gravity dam. Next is barrages. A barrage dam is a special kind of dam which consists of a line of large gates that can be opened or closed to control the amount of water passing the dam. The gates are set between flanking piers, which are responsible for supporting the water load, and are often used to control and stabilize water flow for irrigation systems. And embankment dams. Earth embankments have been used since the earliest times to impound and divert water. They are simple, compact structures that rely on their mass to resist sliding and overturning and are the most common type of dam found worldwide. Modern haulage methods and developments in soil mechanics since the end of the 19th century have greatly increased the safety and life of these structures. So there are several types of embankment dams. For example, rock-fill dams. The rock-fill dams have a relatively narrow and permeable red or clay core inside the dam, but most of the dam is constructed of permeable rock fill, which by itself will be incapable of retaining water. The impermeable membrane in these dams is the clay core. Next, concrete face rock-fill dams, or CFRD, is a rock-fill dam with concrete slabs on its upstream face. This design offers the concrete slab as an impervious wall to prevent leakage and also a structure without concern for uplift pressure. In addition, the CFRD design is flexible for topography, fast to construct, and less costly than earth-fill dams. Next is earth-fill dams, also called as earthen dams, rolled earth dams, or simply earth dams, are constructed as a simple embankment of well-compact earth. A homogeneous rolled earth dam is entirely constructed of one type of material, but may contain a drain to collect seawater. And last one is asphalt concrete core, a type of embankment dam which is built with asphalt concrete core. The majority of such dams are built with rock or gravel as the main fill material. And now we will look at by size. So international standards, including International Commission on Large Dams (ICOLD), define large dams as higher than 15 meters and major dams as over 150 meters in height. The report of the World Commission on Dams also includes in the large category dams such as barrages, which are between 5 and 15 meters high with a reservoir capacity of more than 3 million cubic meters. So there are several benefits of dams, which is to provide water for domestic, agricultural, and industrial purposes, provides employment for local people, controls and reduces sedimentation, provides fishing and opportunities to local people, to increase vegetation cover, control and reduce floods, and last one to bring out social uplift in area. And the general cause of failure in constructing the dams is internal erosion or subsurface erosion of fine-grained material, overtopping, sliding or slope failure, earthquake, rapid drawdown, substandard construction material techniques, and geologic instability in area. So now we will look at background of construction. So why are we building this dam? As we all know, Melaka is one of Malaysia's states with a fast-growing population. Furthermore, this state is famous as a travel spot for tourists. However, Melaka is undergoing a water supply shortage. It is worsened since the rapid development and growing urban population as well as climate change. The state government has announced a scheduled water rationing exercise to combat this crisis, as the water level in the dams was at a critical level. So to solve that problem, Melaka must propose to build a new dam in order to resolve this issue. A new dam is a good solution to address Melaka's water shortage and resolve water rationing exercise. When a new dam is built, there will be many benefits for the people, including the roads that will be built, sufficient electricity supply, and flood mitigation. Most importantly, the locals will get sufficient water supply. Scheduled supply was an effective way of educating consumers on the importance of prudent water use, but the new dam must be constructed quickly to increase the amount of water stored and avoid a water crisis. The main objective of the project is to build and construct a new dam for 30 kilometers square of reservoir area at Melaka by its from the various scope of engineering survey. To complete and finish a big project like this dam project, we must have a good combination of various scope of work. This is because each type of scope of work plays a different role to build the 30 kilometer square dam. Besides, the objective of the project is also to build 30 kilometer square dam at proposed spot at Melaka to help solve the water shortage problems which is currently faced by the people of Melaka. With the construction of this dam, we are looking forward to resolve the water rationing exercises and prevent future water crises. So next, my friend will explain about the scope of work.
Alright, now I will explain about scope of works. So in scope of works, we divided it into two parts. First is project overview and the second one is project scope. Okay, for project overview, as we can see here, this is the map area for our proposed location of the dam. Uh, so the yellow line is the dam and the red line is a 500-meter border from the dam. So this is the river. It flow from up here to down, and for our proposed location, it is located at Sungai Batang Melaka, Alur Gajah Melaka. And it is a suitable site due to its topographical properties. And our dam is a concrete gravity dam that is 300-meter long, and it is also can contain a maximum volume of 30 kilometers square water capacity. In order to maintain the safety of the dam in a long period, we will monitor the dam using geodetic surveying system. Alright, for the second one is project scope. So we divided our project scope into three parts. The first one is before construction of dam, second one is during construction, and last one is after construction of dam. So there are many scope of works that included under these three parts. For before construction of dam, there is for example is examine the availability of water, and second one is examine the topography of the site, reconnaissance survey, preliminary survey, and lastly final location survey. So next, for during construction, mostly it is about setting out survey during the construction, and After cross-section of them, there is SBEU survey and monitoring survey for quality control. So all of this scope will be explained more in methodology of works. So now we will be moving on to survey instrument and software.
So there are several survey instruments and software that will be needed in order to survey and construct the dam. So firstly is UAV to carry out aerial survey to find possible site for dam construction and to identify terrain and examine topography. Second, prismatic compass to find bearing and traversing. Level staff to determine difference in height between points or height of points above datum. Staff bubble to ensure staff is held in vertical position. Automatic level to is a leveling instrument to be used with level staff. Next, photo station to measure vertical and horizontal angles and slope distance for traversing. Tripod to hold several instruments. Prism used as target for distance measurement. Pole to mark position of station. And GPS to obtain location, distance, and height measurement. And we also need stream gauge instrument to measure the flow of river and water level, and several software like IGSoft Metashape to process raw image from drone or UAV, CDS to process data collected from total station, and AutoCAD to draw data received from CDS and collect data from GPS.
Okay, next one is methodology of works. So when we want to start a construction project, we need to do a planning. A plan that consists of everything that needed to be done from the start of the project until it is built. To build a dam, there is three stages of process: before construct the dam, during construct of the dam, and after construct the dam. There is a lot to do before constructing the dam itself because we got a flowing river to be stopped first. Considering this, there is many techniques that needs to be applied and involving many professionals from various fields. Okay, so before dam construction, the first one is we will examine the availability of water. When we wanted to construct an irrigation project like this, first of all, we need to do an observation of the presence of water and its availability. Since this project is to construct a reservoir dam, we need to calculate does the water in the river will support the desired water capacity for the residents in Melaka. For this project it is Melaka. The availability may be of different types, but proper examination is required before we do our construction. And so this is some important observation that needed to be focused on. So if there is any river flowing in the area, we should know the type of river, whether it is perennial or inundation type. If it is perennial, then the water is available throughout the year. If it is inundation river, then study its previous yearly discharge. The second one is the river should meet the requirement of water in that area. And last one is suitable site will be available to construct an irrigation project. So we need to consider the availability of water before we find a suitable site for our dam to be located. The next one is to examine topography. After we investigating the water availability, topography map of the area is studied. This study is more useful when marking the tentative alignment for irrigation project. The behavior of agricultural lands are examined in this stage. And the third stage is selection of construction site. When plenty of water or major source of water is available, then the location to construct an irrigation project is selected. So the selection of site is done by considering these 5 points. So the first one is the soil survey is conducted by boring and pile testing to know about the foundation depth required. Second one is sufficient basin area should be available and the capacity must fulfill the required demand. The site should be easily accessible. Materials and labor should be readily available. The next one is the allowable bed slope should be maintained as far as possible in the canal. And the last one is the structure should not submerge valuable lands and area. The next one is river gauging. So river gauging is measuring of water discharge at point. The point in this case where river gauging is conducted is the site selected for project. After conducting river gauging, we will obtain these following details. The first one is the discharge of river is calculated on daily basis and the yearly discharge records are studied. The high flood level and lowest water level are recorded based on the all observations. And to find out the possible setting of riverbed, silt analysis is conducted and manual value of fine silt is recorded. Okay, the next stage is marking of CCM. CCM is the cultivable common area, which is mainly fit for cultivation of crops. The area under this category should be marked on the topography map. So this is an example of topography map that marks the vegetation and agricultural. So we need to produce this type of topographic map so that the construction should not disturb or damage this area, and required damage discharge can also be known. Okay, the next one is marking of tentative alignment. So after the selection of site for irrigation structure, it is time to select the tentative alignments for canals or branch canals. These alignments should be marked in topography and contour maps. Marking should be done as follow steps. The first one is the alignment mark should cover the whole area when it is cut into canal. The alignment should minimize the earth filling and cutting costs. It should not pass through valuable agricultural lands, religious places, and etc. It should cross rivers, roads, rails, and etc. perpendicularly. Okay, after we done marking the tentative alignment, we can go to the next stage, which is reconnaissance survey. So in this survey, we actually provide many details. So some of the details is magnetic bearings of lines of the traverse along the alignment are recorded, and approximate distance are also measured. The next one is past records of floods in the area are noted. If there is any river across the alignment should cut the river across its shortest width. Eliminate alignments that passes through religious places and valuable lands. For this, if they are unavoidable, they are marked as special areas and suitable compensation should be provided. Okay, next is preliminary survey. After we conduct reconnaissance survey, a suitable alignment are selected for preliminary survey. The preliminary survey has to be extremely accurate as the estimate of cost, final location depend entirely on this. So this is the following steps that are involved in preliminary survey. Pillars are constructed on both banks of river and they represent the center line of irrigation project. Similarly, pillars are constructed to mark the center lines of headworks for both bank canals. Boring is done along the center line of irrigation structure to determine the depth of foundation, and a permanent benchmark is created and its value is noted by connecting it to the nearby GTS benchmark by fly leveling. And there are many more details actually for preliminary survey. Alright, the next one is plan table survey or preliminary survey is conducted on both sides of alignments up to 100 meter and road survey map is prepared. Longitudinal leveling is conducted within interval of 20 meter. Cross leveling is conducted with an interval of 100 meter. Permanent benchmarks are arranged with some interval gap along the alignment. Water table level is studied on both sides of alignment covering up to 200 meter. Soil along the alignment is surveyed. The details of road and railway crossings are noted to design cross drainage works. At river crossing, the cross-section details of river are noted. The cross-section of river are taken on both upstream and downstream sides with covering of 500 meter distance. The next one is we need to prepare of drawings, and these are some drawings that we will be prepared. Road survey map, longitudinal section with formation level, cross section with formation level, contour map along alignment, design of curves with setting out table, mesh diagram for earthwork. And this is some office work that also we need to be prepared. So we need to do an estimation for earthwork and for cutting and banking for main and branch canals. Total land width required is marked on the route survey map. A design and estimate is prepared for the dam, headworks, cross drainage works. An estimate of payable compensation is made if there is any compensation need to be done. And the total cost of the project is also calculated in this stage. So the preliminary survey stage. And the last stage in before the construction is final location survey. So in final location survey, it is most economical alignment among all is selected and final location survey is conducted. In this final stage, following steps are involved. Center line of final alignment is marked with pillars and pegs. The width of alignment is also marked by the pillars. Similarly, for the branch canal also, pillars are marked. Final eligible properties for compensation are recorded. Okay, and that's it, the final stage for before dam construction. So we will moving on to during dam construction. Okay, so during dam construction is mostly about setting out survey. Setting out survey is very important when preparing for any type of construction work actually. Setting out is the reverse of surveying. What is meant by this is that whereas surveying is the process of producing a plan or map of a particular area, setting out begins with the plan and ends with some particular engineering project correctly positioned in the area. Basically, a setting out survey involves transferring a building design onto the land itself so the builders can follow it during construction. Setting out is the establishment of the marks and lines to define the position and level of the elements for the construction work so that many so that works may proceed with reference to them. This process may be contrasted with the purpose of surveying, which is to determine by measurement the position of existing features. And these surveys are important because they allow for the construction to be done within the legal boundary, which is vital to ensure no boundary disputes later on. And the second one is they enable the construction team to build exactly to plan as markers are physically laid out in front of them. Okay, after setting out survey is done, we will go to after dam construction. Okay, actually setting out survey is going throughout all the construction process. So when the construction has progressed, so the setting out survey will be progressed too. And setting out survey may be carried out until the end of the construction. And the next one is after dam construction. So there is two stage of after dam, not two stage actually uh, there is one survey that need to be done, which is as-built survey. So as-built survey is actually uh, built upon the base map of a project and include research at local agency, ground level topography data, and the documentation of visual site improvement. The advantage of this as-built survey is a new base map can be updated to show the current condition of the site. By doing the survey, we will know the exactly new condition of the dam. Does it accurately follow the best plan or not? In this case, the as-built plan will be the new plan of the already constructed plan. And the last one is monitoring survey. Monitoring survey is actually a quality control for the dam. Large dam needs a careful safety control along its lifespan since its failure might cause great losses in life and properties. So the purpose of monitoring survey is to determine if any horizontal or vertical movement occurs after the construction and in later years. If there is an unusual movement, it may indicate a failure. So in order to monitor the quality of the dam, we will use geodetic surveying systems. This system consists of a triangulation network and a geometric leveling line. The monitorization of horizontal displacement of 16 object points on the downstream face and vertical displacement of 10 object points on the with sub-millimetric accuracy. It was important that this system had a very simple configuration so it could be observed by a small team in a short time with the use of one precision electronic theodolite and one precision optical level with infrarods. And this is an example picture of how this system is work actually. Okay, now let's proceed to the next one, which is milestone of project.
Okay, Assalamualaikum. Today I want to present about our Gantt chart project. Our Gantt chart project is about 30 kilometer square dam in Melaka. Okay, our scope project is examine the water availability, examine the topography, selection of site, river gauging, making a CCM, marking of tentative alignment, reconnaissance surveying, preliminary surveying, final location surveying, setting out surveying or construction surveying, SBEU surveying. Okay, let's take a look. For the first one is examine the water availability. The starting date is 1st of June 2020. The duration time is 21 days. Then we examine the topography. The starting date 1 of July 2020 and the duration time is 21 days. Then we go to selection of site. The starting date is 1 of August 2020. Then the duration days is 61 days. Then we go to river gauging. The starting date is 1 of November 2020 and the duration time is 21 days. Then we go to marking CCM. The starting date is 1 of December 2020 and the duration days is 21 days. Then we go to marking of tentative alignment. The starting date is 1 of January 2021. Then the duration days is 21 days. Then we go to reconnaissance survey. The starting date is 1st of February 2021. Then the duration time is 28 days. Then we go to preliminary surveying. The starting date is 1st of April 2021. Then duration of time is 30 days. Is exactly 1 month. Then we go to final location surveying. The starting date is 1 of June 2021. Then the duration days is 21 days. Then we go to setting out survey or we call construction survey. Starting time is 1 of July 2021. It's take a too long time because it goes with construction and its take duration is 730 days. Then SBEU survey, the lastly SBEU survey, the starting time is 1st of August 2023. Then the duration days is 21 days. So that's all. Okay, we continue to our presentation is project cost estimation. We go to table 1 unit price of cost estimation. We go take a look at unit price of construction material. In the construction material, we have gravel draining backfills, stone for masonry, stone for gabion, bricks, reinforcement bar 30 mm or under, reinforcement bar 60 mm or over, dynamite ANFO, detonator, cord, detonator relay, ship steel, wire mesh 100 x 100 x 5, timber for form, sod fencing, fertilized soil, asphalt, bitumen, scaffolding. Then this is a unit that they use is meter cube, kilograms, piece, meter, meter square, and ton. And dimensionless unit is unit. Then we take a look at price of construction labors. Price of construction labor, we pay them money to work with us. And we have a carpenter, plasterer, chief steel bar worker, Gabriel net maker, blasting master, miner, and technician. Okay, I will explain as just example. For carpenter, when they work with us, we will pay them 50 ringgit 74 cents per day. Then when he or she work overtime, they will get extra pay 3 ringgit 68 cent per hour. So who get our tender for this our construction, they will very lucky, and they will get more payment from us per month. This only per day only. Okay, next we go to the table 2 main quantities. Main quantities to use for the cost estimate of the dam. Okay, the main quantity for the cost estimate Melaka Dam, we have preparatory works, diversion works, permanent works, temporary equipment, power station, cyber dam, roadworks, disposal area, and outlet electric power gate. First, we go to the preparatory works or clearing and grubbing. First, we have mobilization, then temporary road of disposal area, then we have road works, then the unit use of it is LS m or meter. This is a quantity that we need use. Second, we go to diversion works or tunnel digging. The length of tunnel we need to build is 340 meter. Then we have diversion length around 7.5 meter times 7.5 meter semi-hose shaped tunnel. Then we have an open intel outlet and coffer dam. The unit they use is size. Then the quantity we need only 2. Both of 2. Then we go to the permanent works. Permanent works we have excavation, artificial plug, concrete works, artificial concrete abutment, groundworks, consolidation grout, curtain grout, rim grout, crown grout of dam. Or permanent works, we can say that this is a concrete gravity dam. First, the unit they use is meter cube, meter, and size. This is what quantity we need. Okay, next we go to the temporary equipment. So we have the concrete plant, tower crane, feed plant. Okay, this is the unit used, but in for feed plant we use the unit ton per hour. Because we calculate the rate. This is the quantity we need. Okay, next we go to the power station. We have excavation, concrete construction, and power station 7,900 kilowatt volt. Okay, they use meter cube and set. This is a quantity that we need. Next, we go to the cyber dam. In cyber dam we have the excavation and concrete works. We use meter cube, and this is a quantity we need. to build it. 7. We next go to 7. This is a road works. On the roads work, we have earthworks and pavement, excavation rocks, surface cost concrete 25 centimeter, beacon signal, steel bridge, just only 5 only, and we use 2 meter square and meter cube and ton for each unit. And this is what we need is quantity we need. Then we go to the disposal area. We have left bank and right bank and embankment or backfilling. We use meter cube units, and this is quantity we need to use to build it. Number 9, lights, outlet and electric power gate. First, we have intake gate and conduit pressure pipe. We use unit is T or ton. This is a quantity we need. Next, we go to table 3, estimate direct cost. Okay. Melaka Dam construction direct cost is estimated based on the main quantities we show in table 2, like this. It is the main quantities. Okay. The estimation result of direct cost for Melaka Dam is shown in the table 3. This is table 3. Okay, let's go. For starting, we have mobilization and demobilization. This is amount foreign currency, and this is local currency, and the total in ringgit, and the foreign in yen, and this remarks or total of number. Okay, foreign currency we use in yen, in Japanese money. Then we have number first we have generate item. We need quantity 1. This is a local currency price, and the total price we must pay. This is a foreign price in yen. Okay, we go to the next we go to the diversion works. In diversion work we have care water, earthworks, excavation soil, excavation rocks, backfill, excavation support and protection works, concrete works, and drilling and ground works. And the subtotal we use for foreign currency is around 27 billion yen. For local currency we use amount around 19 trillion. Okay, we go to the concrete gravity dam. So in concrete gravity dam we have care of water, excavation and support works, protection and support of excavation. Dam concrete. In dam concrete we have reinforcement concrete cover dam. Then we have drilling and grounding works, and consolidating ground, curtain ground, and rim ground. In this subtotal in foreign currency is around 22 billion. For local currency it's around 95 trillion ringgit Malaysia. Then we go to artificial concrete abutment. In this we have care of water, earthworks, protection and support works and concrete works. Then we have the subtotal in local currency is around 210 billion ringgit. So we go to the 7M. 7M, we have a care of water, earthworks, excavation soil, excavation rocks, backfill, concrete works. And subtotal when we need is 50,600 yen for foreign currency. Then we have for local currency it is around 478 million. Okay, let's go to the instrumentation. Instrumentation for them. We have groundwater level, seepage measuring, plumb line, strain gauge, embedded instrument, and cabling. And the subtotal in foreign currencies is around 42 million yen. And for local currency is around 206 million ringgit. Let's go to the works, roadworks. Roads we have earth and pavement works, excavation rocks, concrete surface wearing cost 25 centimeter, concrete and masonry works, girdering road markings and signs, steel bridge. Okay, the subtotal that we need is the subtotal is foreign currency is around 7 million pound. For local currency is around 13 billion ringgit Malaysia. For then we go to the power station. In the power station we have building works, water supply and sewage water system, civil works, asphalt paving, and excavation. Then the local foreign currency is around 3 million yen, and for the local currency is around 6 billion. Then we go to the electrical works. Is subtotal is around for local currency is around 209 million. We go to the operation and maintenance equipment. We know maybe we will not use because the zero we will not use. Then total civil works is in foreign currency is around 834 million, and for local currency is around 116 billion, very much high. Then we go to the hydromechanical. Maybe we in hydromechanical we have diversion gate and penstock. We use the foreign currency is around 46 million yen, and the local currency is not stated. But its total we need is around 40 billion. We need to get. Then we have electrical and mechanical equipment (E&M). Foreign country currency we need around 217 million yen. And for local stated, total direct cost is around for foreign currency is around 869 million, and local currency is around 116 billion. This is very high difference. You can see local currency and foreign currency. The factor, because the factor is cause these things difference, or because of money price. Then we total of sum all for in ringgit Malaysia billion is around 8,000 billion. For foreign or yen is around 95.1 billion. Okay. For the last, we go to the table for estimate project cost. Project cost in the consideration of land acquisition 3%, administration 5%, engineering fee 10%, contingency is around 10%, is shown in table 4. And as a contingency 10%, it was estimated as a 10% for the construction cost, and land acquisition and compensation, administration expense, and engineering service. This is a summary of project cost of Melaka Dam. Okay, this is that we discussed before, mobilization, demobilization, until M&E. Then total cost we estimate is around, for foreign currency portion, is around 3 billion, and local currency is around 116 billion. Then the total amount that we need to pay is around 192 billion. And equivalent for these two portion is 9 billion. Okay. For the direct cost, sorry, mistakes. Our direct cost in ringgit Malaysia in million. For foreign currency is around 3,000 billion, and local currency is 106 billion. That is same is total direct cost, and the equivalent around 9,000 billion. Land acquisition 3% for foreign currency portion is around 113, and local is around 3,000, and total amount is 5,000 in ringgit Malaysia, and the equivalent is around 119. Then we have administration. Administration is 5%. For foreign currency portion is around 189. Then engineering fee for foreign currency portion is around 378, and subtotals is 4,462, and contiguity 10% is around 446, and total is around 4,908. Then for we look at local currency portion, it's around 3,000 for land acquisition. For administration, it's around 5,000. For engineering fee, it's around 11,000. And subtotal is around 136,000. And contingency is around 13,000. And the total all is around 150,000. Then we go to the total amount. Total amount in ringgit Malaysia. For direct cost is around 192,000, and total amount for land acquisition is around 5,000, administration around 9,000, and engineering fee around 19,000, and subtotal is 227,000, and contingency is around 22,000, and the total all is around 20 224 259,000 ringgit Malaysia is all in ringgit Malaysia. For equivalent, we can see that direct cost is around 9,000, and land acquisition is around 119. Administration is around 475. Engineering fee is around 951 engineering fee. Subtotal is all 11,125. And contingency is around 1,120. And the total all is around 200 12,237. Okay, that's all. Then we'll continue to Afi. Thank you.
Okay, let's continue to output. Okay, so this is an example of map that we produce. So this map, it shows the position of the dam in the location, proposed location. So the yellow one here is the dam, and this is the river, and at the side is the green area, which is mostly covered by forest. Okay, so uh, in this small map shows the position of our dam in Melaka district. So the red dot is the location of our dam. Okay, so the next one is, this is a sketch of a gravity dam. Okay, so it shows, okay, this is the dam, and this is the spillway. Spillway is which is where we spill out the water to run here, and then this is the outflow, and turbines and generators for hydroelectric. Okay, so this is the cross section for gravity dam. Okay, and the last one, and this is the calculation of a gravity dam. Okay, in this example, it shows the calculation uh, of the accurate calculation for a gravity dam, because gravity dam is a type of dam that use the gravity to hold. So this is the accurate calculation for gravity dam. Alright, that's all from me. Let's continue to the next one.
So for summary, this is a proposal for engineering survey project 2 consisting of a 30 km square dam at selected place in Melaka. The main outcome for this project is to show the various scope of engineering survey that helps to complete this project. There are several scopes of works involved in this project, which are doing mentor recruitment, understanding dam design, supervise field activities, estimating costs and labor requirements, determine work system, and etc. The project involves both hardware and software and development. In the hardware part, we must collect and get the data needed by using the instruments that we have listed. The combination of hardware and software gives the final output, which is a plan that will be used by the engineer to build the dam. However, the plan will be produced, it will go through the specific analysis and will be checked by the engineer in charge and project manager to make sure all data have been processed are accurate. This project goal is to help solve the water shortage problems which is currently faced by the people of Melaka. With the construction of this dam, we are looking forward to resolve the water rationing exercise and prevent future water crises. Nowadays, technologies are very advanced and very efficient, which give a lot of benefit to construct the dam in a very short time. In this way, we can build the dam quickly since the state's water level is in a critical condition, and we need to store more water to be supplied for the people of Malacca as per daily usage. Even though scheduled water supply is effective, but the dam must be constructed quickly in order to avoid future crises. Moreover, it will give many benefits for the people, including the roads that will be built, sufficient electricity supply, and flood mitigation. Most importantly, the locals will get sufficient water supply and settle the water shortage problem. Finally, as a conclusion, the construction proposal of this new dam make a large impact to the state of Melaka and its people as it gives many benefits to others. So it is important to produce an accurate plan in order to proceed with the building of the dam. So that is the end of our project report. So firstly, we would like to thank God for the wisdom and physical help that He provided us with, which enabled us to complete this project report successfully. This project will also not be done without the cooperation and efforts ensuring commitment from our team members, Muhammad Afiq bin Muhammad Shahiran, Muhammad Zami Hilmi bin Zainon, and Nur Machita Betinas. We will also like to express our huge gratitude towards our lecturer for this subject, Dr. Abd Wahid bin Rasib, who has exposed us to the process of engineering survey project and helped us to complete this task. His assistance and support have guided us in this project development and progress. Last but not least, not to mention our seniors and course mates who have given us with abundance of support, helped to share many great ideas and willing to share useful information, which are very beneficial for our project. A million thanks for your guys' help and encouragement. So that's all from us. Thank you.